All right, so what we want to do is we want to graph r is equal to sine theta. R is equal to sine theta is a polar equation that we will graph on this polar coordinate axis here, polar axis here. So let's do that by acknowledging first the symmetry. As you graph these polar equations, one thing that might be helpful for you to do is have some kind of general idea of what it is that you're graphing. Sometimes that's helpful. And I've got this pre-calculus book here, 3 sine theta, r is equal to 3 sine theta. You can see here that in graphing r is equal to 3 sine theta, r is equal to a sine theta, you're working with a circle. So that's nice to know that you are in the process of graphing a circle before you begin this process. One of the major things that really helpful in graphing polar equations is to check for the symmetry of whatever it is you're working with. All right, and we do that by substituting in r, negative theta, or r theta, or, negative r, negative theta, negative r, negative theta, or negative r theta. All right, and one of the things that we talked about last week was that this topic that we're discussing, there's a lot of information you have to know in advance prior to really understanding fully what I'm talking about. One of the things that you've got to know, and before we even graph, before we even begin the process of graphing this, one of the things that I'll ask my students to be able to do is just look at this equation and being able to see that having an understanding of sine negative theta is equal to negative sine theta. I'd ask my students to know that ahead of time. I'd also ask my students to know ahead of time that cosine negative theta is equal to the cosine of theta. It's very important that you know that ahead of time, so that when you substitute in one of these points, negative r, negative theta, for example, if you substitute in negative r here, let's substitute in negative r. Let's get rid of this. Let's substitute in negative r, and then initially we got r is equal to 3 sine theta. All right, so if we substitute in negative r, then 3 sine negative theta, you end up with sine negative theta, which we've stated previously. Sine negative theta is negative sine theta. So we have negative r is equal to negative 3 sine theta. You divide by negative on both sides, so you get r is equal to 3 sine theta. So you end up with the same thing that you started with. And that's what we are testing for. If you substitute in negative r, if you substitute in negative r, negative theta into your original polar equation that you're working with, and you end up with the exact same equation as we did right here. We substituted in negative theta, negative r, and we ended up with the exact same equation that we started with. That is a way of testing for symmetry about theta is equal to pi over 2. So because we substituted this into the original equation, we got the same initial equation. That verifies that what we're trying to graph is symmetric about theta is equal to pi over 2. This is the only relationship that using this negative sine theta, sine of negative theta is equal to negative sine theta identity, that's the only one that's easily detectable. That's the only one that's easily detectable. So what I'm going to ask my students to do is to check for symmetry for not only what in the rectangular coordinate systems we call the y-axis, or in the polar coordinate system we call it theta is equal to pi over 2, but I'm going to ask them to check for symmetry across the polar axis and the pole using this difference point here, negative r, pi minus theta, and then for the check for symmetry across the pole using this r is equal to pi plus theta. My experience has been that using negative r theta and using r negative theta won't actually verify the symmetry properly. So let's go through that process right now. All right, so what we're going to do is start with, again, r is equal to sine theta. That's our original problem we're trying to graph. And now let's substitute in negative r, and then pi minus theta. Sine of pi minus theta. All right, and that was also a 3 there. Let's put the 3 there. Negative r is equal to 3 sine pi minus theta. So you end up with negative r, you bring down the 3, and then, as I said earlier in the show, this topic assumes that certain things have already been discussed, certain things have already been clear to you. The sign of this difference can be expanded into sine pi cosine theta minus cosine pi sine theta. That would have to be understood. You would have to have seen that before. So now we have negative r is equal to 3. The sine of pi, that's 0. You would have to have gone into this topic knowing that. And then you have negative cosine pi, that's negative 1. And then the sine theta. All right, so what this simplifies down to is negative r is equal to 3 sine, negative times a negative is a positive, 3 sine theta. Negative r is equal to 3 sine theta. Notice how you end up with something different than what you started with. So what that tells you is that this is not symmetric about the polar axis. This is not symmetric about the polar axis. All right, and checking for symmetry really saves time and really simplifies the graphing process. Let's check for one more type of symmetry, symmetry across the pole. Check for symmetry across the pole. Or in the rectangular system, what we call the origin. All right, symmetry across the pole. All right, so let's start with our original equation once again. R is equal to 3 sine theta. Let's substitute in r and pi plus theta. R is equal to 3 sine pi plus theta. All right, so we get r is equal to 3 sine of pi cosine theta plus cosine pi sine theta. All right, see if we can zoom in just a little bit. Hopefully that helps. And then what we end up with, r is equal to 3 sine of pi again. That's 0, so that cancels all that out. And we end up with cosine of pi, which is negative 1. And you end up with negative sine theta. So again, you end up with something different. R is equal to negative 3 sine theta, which is different from the original equation we were working with, which is r is equal to 3 sine theta. So what that tells you is that this is not symmetric about the pole. It's not symmetric about the pole. So it's only symmetric across what we used to call the y-axis, and when we're working with polar equations, we're going to call it theta is equal to pi over 2. So let's begin the graphing process now. Let's substitute in 0 for r. 0 is equal, let's change this a little bit. Sorry about that. Let's make this column theta, and let's make this column r. I think it'll be a little bit easier that way. Let's substitute in 0 for theta. We get r is equal to 3 sine theta, and then we get r is equal to 3 sine 0. The sine of 0 is 0. You would have to know that going into this topic, so you end up with 0. Sine of 0 is 0. 3 times 0 is 0. So theta is 0. This is 0 degrees here. 0 degrees here, or radians, however you want to look at it. And you end up with 0. So you're looking at a radius of 0. Let's plot another point. Pi over 6, or 30 degrees, however you want to look at it. We get r is equal to 3 sine of 30 degrees, or pi over 6, however you want to look at that. And we get 3 sine of 30 degrees is half. 3 divided by 2, you end up with 1.5. So now you're going to plot the point pi over 6, 1.5. You're going to go up pi over 6, and you're going to extend out a radius of 1.5. This is the angle pi over 6, and I'm going out not 1, not 2, but in between, 1.5. Now, let's plot. Oh, by the way, because this is symmetric about pi over 2, this saves you time in plotting. You could just plot another point. You know, if you've got a point here, you can reflect that point across. Theta is equal to pi over 2 to get another point. Checking for symmetry actually saves you time in the long run. Let's plot the point pi over 4. Let's check the angle pi over 4. Let's substitute that into r is equal to 3 sine of pi over 4, or 45 degrees. Let's substitute that in. This is 45 degrees. This is 30 degrees. All right, and you end up with the sine of 45 is 1 over radical 2. All right, so you can put that in the calculator. 3 times radical 3, and then you divide 2, you get 2.6. This is about 2.6. So you go to the angle pi over 4, 45 degrees, and you extend it out to 2.6. And similarly, you can do the same thing over here. Symmetric about theta is equal to pi over 2. About right there. In fact, so maybe you can see it a little bit better. Let's maybe use green so you can see that a little bit better. Hopefully that's helpful. All right. So now let's check another angle. Let's substitute in pi over 3, which is the same thing as 60 degrees. Substitute that. R is equal to 3 sine 60 degrees. The sine of 60. Uh-oh. Let me check this one more time. I should have multiplied 3 times 1 over radical 2. I think I might have done the wrong thing here. 3 times 1 divided by square root of 2. I should have plotted 2.1. I really apologize for that. Let's plot pi over 4, 2.1. So that point should be about right there. Pi over 4, 2.1. All right. Not this point here. I am very sorry about that. Not that point there. So we're working with 0, 0, this point, this point, this point, and this point. All right. If I could, I would erase that. Let's get that out of there. And let's get this out of there. All right. Let's keep going. All right. So now let's plot pi over 3, which is the same thing as 60 degrees. We get 3 times the sine of 60, which is radical 3 over 2. And let's substitute that. 3 times radical 3 over 2. We end up with 3 times radical 3. And you divide by 2, and you get, that's 2.6. So this is 2.6. This is 2.6, and this was 2.1. All right. So now you end up with 60 degrees. 60 degrees. You're going out 2.6, which is about right there. And again, this is symmetric about the y-axis. You plot 2.6 about right there. And I think we have time to plot one more point to get clarity on what this is looking like. All right, so let's substitute in one more point. Let's substitute in pi over 2. In degrees, pi over 2, that's the same thing as 90 degrees. Let's substitute that into r is equal to 3 sine of 90. The sine of 90 is 1. So we get 3 times 1, which is 3. So you're going to plot the point, 90 degrees, and you go to 3. So what you're looking at, we plotted this point, we plotted these points next, then we went to these 2 points, and then we went to these 2, and I'm hoping that didn't confuse anyone. I erased these 2. These were not correct. And what we ended up with is you end up with a equation of a circle. This was the equation of a circle, and you end up graphing something that looks like that. All right, so you end up with a shape that is actually a circle. And that is our first problem where we've graphed a polar equation.